Hi, I'm Troy Miller.
And I'm Michelle Nursey.
And we'll be talking today about the Venus Express. In this presentation, we'll be talking about the objective of the satellite, the major components that make up the satellite, and we'll be talking about the propulsion system in depth. The Venus Express was launched November 9, 2005 to collect various data about the atmosphere of Venus. It spent 486 days orbiting Venus until it deorbited in 2014. The data was collected to give insight into the evolution of Venus, and since Venus was so similar to Earth, the data could provide useful information about the history of our planet as well.
The major components of the Venus Express are the power systems, the propulsion systems, the communication systems, and the navigation systems. The power systems consist of two solar arrays, which are 5.7 square meters in size, and when they're close to the Earth, they can generate up to 800 watts of power and up to 1100 watts of power near Venus. The energy of these solar powers gets stored in 3 lithium-ion batteries that are on board that can be used when the solar arrays can't see the sun. The propulsion systems consist of the main engine and 4 pairs of altitude thrusters, which can adjust the trajectory of the satellite, the attitude of the satellite, or the altitude of the satellite. The communications with Earth are handled by 2 high-gain dishes that are on the satellite that sit on different faces of the spacecraft, and by 2 low-gain antennas. The larger of the high-gain dishes is used when the satellite is closest or farthest from Earth, and the smaller is used when it's closer to Earth. The 2 low-gain antennas are only used during launch or when it's close to the Earth. Finally, the navigation is handled by a 3-axis system that consists of 2 star trackers, 2 sun sensors, 3 laser gyroscopes, and 3 accelerators that all collect data about the spacecraft's position and orientation so that the thrusters or other methods can be used so that it can fix its trajectory if necessary. A little bit more detail about the propulsion systems on the spacecraft. The main engine could produce thrust of up to 400 newtons and was used to accelerate and decelerate while entering or exiting orbits. The 4 pairs of attitude thrusters each have about 10 newtons of thrust each, and they're used to correct the attitude, the altitude, and the orientation of the spacecraft. The propulsion is produced using the 570 kilograms of fuel that's on board, which makes up almost half of the entire spacecraft weight. And finally, the navigation systems collect enough data that they can tell where the spacecraft is in space and its orientation, and they can automatically correct using these thrusters. We'd like to say a big thank you to the European Space Agency website, and thank you for watching.